and welcome learners. First of all, I would like to thank you all for opting the postgraduate diploma in applied statistics program PGDST. In current session, we will discuss on the topic measure of central tendencies, which is the part of the unit 1 of the course MST 002 descriptive statistics of PGDST program. This session is also helpful for the learners for the course BST CT 131 descriptive statistics and probability theory of BSc General in Statistics program, which is now under development. Myself, Professor MANISH TRIVEDI, faculty in Statistics, School of Sciences, IGNOU, New Delhi. This whole session will be devoted to discuss measure of central tendency, arithmetic mean and different methods of calculation of arithmetic mean. As the course title is descriptive statistics, so first of all we will discuss that why descriptive statistics is taught and what is descriptive statistics. Descriptive statistics helps us to describe, show or summarize data in a meaningful way. Descriptive statistics do not, however, allow us to make conclusions beyond the data we have analyzed or to reach on the conclusions regarding any hypothesis we might have made. They are simply a way to describe our data. If we simply present our raw data, it would be hard to visualize that what the data is showing, especially if there are large number of values or information in the data. For example, if we put 50 or 100 values of height of the students of a class, then it does not show any meaningful or visualization to the viewers. When we use the descriptive statistics like measure of central tendency, measure of variations, and then we conclude or concise or summarize the data, then it will be meaningful. Descriptive statistics therefore enable us to present the data in more meaningful way, which allows simpler interpretation of the data. Now we come to the topic measures of central tendency, which is the part of this course. A measure of central tendency is a single value that attempts to describe a set of data by identifying the central position within that set of data. They are also called the statistics of location and are complement of statistics of dispersion, which provide information concerning the variance and distribution of observations. In the univariate context, the mean, median and mode are the most commonly used measures of central tendency, but geometric mean and harmonic mean are also used to compute average in special cases. These are the computable values on a distribution that discuss the behavior of the center of a distribution. Every set of data has a central value around which the most of values of the variable tend to cluster. The value or the observation which represents the whole series is neither the lowest value in the series nor the highest, and it lies somewhere between these two extremes. If we wish to know the central value in a set of data, some measures of central tendency, also known as measure of location, are computed. These measures are popularly known as average. Now we discuss some famous definitions of measure of central tendency or averages, which have been given by popular statistician. Professor Bowley said averages are statistical constant which enable us to comprehend in a single effort the significance of the whole. Professor Simpson and Gaffa stated that a measure of central tendency is a typical value around which other figures congregate. Professor Wagg said that an average stands for the whole group for which it forms a part, yet represents the whole. So, after discussing these definitions of measures of central tendency, now we should discuss why measures of central tendency are used. What is the significance of using a measure of central tendency? As such, measures of central tendency are sometimes called measures of central location. They are also called or classified as a summary statistics. A measures of central tendency is a single value that attempts to describe a set of data by identifying the central position within that set of data. A measures of central tendency represents all the measurements made on a group. It gives a concise description of the group as a whole. When two or more groups are measured, the measure of central tendency provides the basis for comparison between them. So, by discussing the significance, we can understand that measures of central tendency are used to summarize the data, to represent the whole group, and it enables us to compare the two or more than two groups. After that, we can now discuss the properties that should be attained by a good measure of central tendency. First of all, a measure of central tendency should be simple to calculate and easy to understand, so that it should have the wider applicability and understanding to the layman also. It should be rigidly defined so that it has a definite and fixed value. It should be liable for algebraic manipulations, otherwise it will not be useful in further statistical analysis and its utility will be limited. It should be based on all the observations, since in the definition of measures of central tendency stated that it is a representative of the whole mass of data. It should be least affected by sampling fluctuations, that is, it should have a sampling stability. Here, sampling stability means that if n number of samples has been drawn from a population, then if we calculate the arithmetic mean for all these n samples, then the value of the arithmetic mean should not be differ largely for all the samples. It should be possible to calculate even for open end class intervals. It should not be affected by extremely small or extremely large observations, otherwise extreme observation may distort it and cannot be regarded as a representative value of the entire data. So, after discussing the properties that a good measure of central tendency should have, we discuss over here the different type of measures of central tendency. There are various measures of central tendency which are used, but we can classify the measures of central tendency in two categories. First one is mathematical measures of locations and second one positional measures. Measures of location, arithmetic mean, mode, geometric mean and harmonic mean are classified under measure of locations. So, now we will discuss the first measure of location, that is measure of central tendency, arithmetic mean. Arithmetic mean, it is also commonly known as simply the mean, also called average in general sense. It is the most popular and widely used measures of central tendency. We always heard that word average in our daily routine, that is average income, average marks, average intelligence, like that. Arithmetic mean is a arithmetic average and is simply the sum of observations divided by the number of observations in a set of data. Now, we will discuss the different methods of calculation of arithmetic mean. As we studied in the first course MST 001, the different type of data. So, there are three kind of data. First one is ungrouped data, that is individual series where the values of the observations are given. Second one is discrete frequency distribution, that is where the discrete kind of values are given with their respective frequencies. Third one is continuous frequency distribution, where the observation of the data are classified into different groups and corresponding frequencies are given. So, here we will discuss the method of calculation of arithmetic mean for these three groups, and there are two methods, that is direct method and shortcut method for all these three groups, three grouped of data. So, now for the first data, that is for ungrouped data, the direct method we are discussing over here. So, for example, if n1 if x1, x2, x3 up to xn, n number of values are given in the data. So, arithmetic mean would be calculated by summing all the n values x1, x2, x3 up to xn and divided by that sum or that total will be divided by the total number of values. So, that is also equal to summation xi divided by n, where summation, this symbol is a Greek symbol that reflects the total of n number of value given in the data. Let us take the example to understand more clearly. So, if the run scores by the 10 players are given over here, so we can calculate over here the average score of 10 players by using the direct method formula. What we do? We take the total of the scores of these 10 players and divide by the total number of players, that is 10. So, total is 170 and divided by 10. So, 17 is the result. So, that means the mean score of the 10 players is 17 runs. Next, for ungrouped data, the shortcut method can also be used. Shortcut method is used when the observations, the magnitude of the observations in the data are very large. So, this shortcut method reduces the magnitude of or the values of the observations in a less amount, and then the arithmetic manipulation will get easy. So, shortcut method, if x1, x2 up to xn are the n observation for variable x and we choose a constant capital A as a assumed mean, and then we take the deviations of all the observation x values from this assumed mean, and the deviations are coming in terms of d1, d2, d3 up to dn. Then we use the given formula, that is x bar equal to A, that is assumed mean, plus summation of di divided by capital N, where di is the deviation. Let us have the example to get more clarity. Shortcut method we are using over here for the same problem that we have taken for the direct method. So, number of players are 10, scores are given in the second column. Let us see on the table. So, out of the scores we choose here the constant A, that is assumed mean 18, and in the third column DI, that is deviation, we have calculated of each and every value of scores to this 18 and calculated the summation of DI, that now coming in our example, that is minus 10. Now, we are using the formula for the shortcut method and put the value of capital A summation DI and capital N. Then again we are seeing here that the answer, the result is 17 runs. So, see here the 17 runs, the average score of 10 players, that is same as we have calculated by the direct method. So, there is no difference in the result whether we are using the direct method or shortcut method by calculating the arithmetic mean. Now, we come to the discrete frequency distribution and we are using the direct method to calculate the arithmetic mean. So, here if x1, x2, x3 up to xk are k distinct values for the variable x with associated frequency f1, f2, f3 up to fk respectively, then the arithmetic mean will be calculated by taking the product of x1 with corresponding f1, f2 with corresponding f2 up to fk with corresponding value xk, and then we take the sum of all the product of xi with respect to with corresponding the fi's. So, we get over here the summation of fi xi in the numerator and we divide this sum by total of all the frequencies f1 plus f2 plus f3 up to fk, that is also denoted by capital N. Now, let us we take example to understand this formula or the method. The following table gives the data related to the marks that is given out of 10 of 100 students in a statistical test. So, in the first column the scores are given, that is 0 to 9. Frequencies are given in the second column, that is the number of students who got the marks out of 10. So, for this direct method what we do, we multiply the x values, the score values to its corresponding frequency and calculate the sum of all the xi fi values, and in this example it is 535. So, using the formula, that summation fi xi divided by summation fi is 100, the total number of students, and summation fi xi is 535. Therefore, 5.35 is the average marks of the students in statistics test. Now, we come to the shortcut method for the second kind of data, that is discrete kind of data. If x1, x2, x3 up to xk are the k distinct values for the variable x with associated frequency f1, f2, f3 up to fk are given, then again we choose a constant capital A as a assumed mean out of the k number of values, and h we chosen as a constant. We calculate the deviations of x values from the assumed mean. These are denoted by d1, d2, d3 up to dk for the deviations of x1, x2, x3, xk from the A, and then we calculate, take the total of Fi di, that is the product of the deviations with the corresponding frequencies, and divided by capital N multiplied by h, that is the, here h is taken the difference between the k values x1, x2, x3, xk, and A is the assumed mean. By putting these values in the formula, given formula, we can calculate the arithmetic mean. Let us see one example here. So, in that example, wages of 125 workers have been given. There are the 7 different wages are there, and the corresponding number of workers who are getting these wages are given. So, now let us see that in the table, the first column wages are given, these are 200, 210 up to 260. In second column, the number of workers have been given, that is the frequencies, and the total frequency is 125. Now, in the third column, we calculate the deviations, that is deviations of xi corresponding to A. Here A we have taken out of these 7 xi values wages, 230 has been chosen as the assumed mean, that is capital A. So, deviations has been calculated in the third column by taking the deviation difference of xi value with respect to the A and divided by h. Now, in the fourth column, we have multiplied the deviations with the corresponding frequencies, and at last we calculated the summation of Fi di, and that is here minus 26, and summation Fi, that is capital N, is 125. So, now A 230, H there is 10, and summation Fi di is 26. We put these values in the formula, and now after putting the formula, we get the average wages of 125 workers are 227.92, that is 228. Now, we come to the third kind of data, that is continuous frequency distribution, and the direct method for calculating the arithmetic mean we discuss over here. If x1, x2, x3, xk are the mid values of k groups formed for the variable x, as we have already discussed, that continuous frequency distribution is a setup or distribution which is under which the whole data, the number of observations are classified into groups and corresponding frequencies are given accordingly. So, for this kind of data, the directly we can calculate the arithmetic mean by taking the mid values of the classes or the groups, and we multiply these mid values with the corresponding frequencies of the classes, and we calculate the summation Fi xi, that is the sum of product of the mid values x1, x2 up to xk with corresponding frequencies f1, f2 up to fk, and then the total will be divided by the total of frequencies, that is summation of f1 plus f2 up to fk. So, this is the formula for the direct method of calculating arithmetic mean. Now, let us take the example for more clarity. The frequencies are given for the 7 different classes under which the data has been classified, and we will use the direct method, direct formula. So, in the first column classes are given, mid values has been calculated in the second column, frequencies in the third column has been given. In fourth column, we multiply the these mid values with the corresponding frequencies, and at last we calculate the sum of product of the xi with corresponding frequencies. So, here summation f I x I is 2515 and summation f I is 70. So, the mean can be calculated over here by putting the summation f I x I and summation f I values, and this for this data the average age that is given in the classes is 35.93, that is around 36 years. Shortcut method. By shortcut method, we can also calculate the arithmetic mean for the continuous frequency distribution. If x1, x2, x3 up to xk are the k observations taken as mid values of k groups formed for the variable x, which has with associated frequencies f1, f2, f3 up to fk respectively, and a that is chosen constant as a assumed mean, and h is a constant where h is the class width. So, in this method again we take the mid values, and out of these mid values we select a constant capital A as a assumed mean, and then we take the deviations of all the mid values from this assumed mean, and this is denoted as d1, d2, d3 up to dn for the data, and then we put the we calculate the sum of the product of these deviations with corresponding the frequencies and divided by the capital N, that is totals of the all the frequencies, and using the given formula. Let us take the example for understanding. The classes are given over here, the 7 classes are given. We have calculated the mid values in the second column. Out of these mid values, one value has been chosen as assumed mean, that is 37.5. In third column, the corresponding frequencies are given, the sum of frequency is 70. In fourth column, we have calculated the deviations of xi values from the assumed mean, that is 37, and we have divided this difference by h, that is the class width, and it is here 5. Now, in the fourth column we have calculated the product of these deviations with respect to with the corresponding frequencies, and the total of the product of f and d is calculated, that is minus 22, and summation of f I is 70. So, now we use the formula and put the values of summation f I d I, summation f I a and h in the formula, and we got here the value, that is average age is 35.93. This is same as we have got the result for the direct method. Now, after that we take here some examples, that is corrections of the arithmetic mean. So, the example is given over here that 80 students were found to be the average value is given 40 of 80 students, the average marks, and 54 the score, one of the score 54 was misread as 84 and the mean had been calculated. Now, we have to find out the corrected mean. So, first of all, in this kind of problem First of all, we obtain the sum of the incorrect observations, that is summation of xi. Here in this problem we have got the sum of xi which is incorrect is 3200. After getting this incorrect sum, the correct sum can be obtained by subtracting the misread value from the and adding the correct value of these observations to the incorrect sum, and then we get the correct sum. Corrected mean now can be obtained by putting the corrected sum of xi divided by capital N, that is the total number of students, and it is obtained 39.625. So, learners, now we should summarize what we have discussed in in this session. So, we have discussed that descriptive statistics help us to describe, show or summarize data in a meaningful way. A measure of central tendency is a single value that attempts to describe a set of data identifying the central position within that set of data. The measure of central tendency summarize the data, represent the whole data and provides the basis for comparison between them. We have also discussed that a good measure of central tendency should be simple to calculate, easy to understand, rigidly defined, liable for algebraic manipulations based on all the observations, least affected by sampling fluctuations and not affected by extreme small or extremely large observations. Arithmetic mean is a mathematical average and is simply the sum of observations divided by the number of observations in a set of data. Direct method and shortcut methods have been discussed in this session for three kind of data, that is ungrouped data, discrete frequency distribution and continuous frequency distribution. Thank you.